Okay, so hi guys, how you guys doing today? All right, perfect. So just a couple more things. I'm still working on the syllabus because the couple things. The Cengage company contact me. They now transfer the course onto my account. So still I'm trying to find it. I couldn't find it this morning, so I don't know why, but I will find it. And also, here's the thing. I have a question. Are you guys okay with the video quality or lecture? Okay, that sounds great, but I'm still trying to improve the quality of the videos. So what I'm gonna do, I might gonna do is, I might also post the lecture videos on YouTube channel. So there's no limitation on the capacity, so you can actually watch much better quality video there. So you can see it from there, but I'm actually recording with the two video recorder over there. So if that works well with the YouTube channel, I'll definitely let you know. Or meanwhile, you can still watch my lecture video on Canvas. But let me try to find out which one is better, and I can always choose the better one for you guys. Okay. Sounds good? Okay, perfect. All right, so that's pretty much it. So once again, because of that, the quality choose kind of issue there. So I'll try to make it, relatively speaking, quite short lecture today. But here we go. All right, so now we're gonna touch on the month of chapter 3. So chapter 3 is all about the arcane. So whenever you talk about the arcane, it is all about the hydrocarbons. And that is fully saturated. So this is fully saturated. Okay? So here's the thing. What do you mean by is fully saturated? So whenever you talk about some alkane, well, it's fully saturated with the hydrogens. That's what it means. Okay. So if there is a double bond or triple bond, so if there's a double bond, that will be R. Do you know what this is? Double bond, alkene, right? You guys remember from the Jenkin 2, was it? Jenkin 2? And if there's a triple bond, it will be R kind. Okay? So this is something what you can see on the bonding between carbons in your organic compounds. So main structure of the organic compounds, obviously carbon, but also with the hydrogen. But when it's fully saturated with the hydrogen, and those hydrocarbons will be called alkane. That means each carbon and the molecule we're only going to have a single bond. Okay? They're only going to be single bond between carbons. Single bond. Okay? You guys know what the single bond is, right? Okay. There will be only one pair of electrons will be shared in some limited space, so they can make some covalent bonds. I mean, they can share the one pair of a valence electron in each carbon. So they can have a quite strong bond there. Okay? So this is what we mean by the alkane. Now, this is something we need to look into more detail this chapter. What I want to point out for this one, before we move on to anything, is they only have a single bonds. So what you need to think about whenever you look at any compound is alkane, is they can always rotate. They can always rotate. So here's the thing. Okay, so whenever you have this structure, you know why I drew like this one, right? There'll be 3 carbons, right? And they're all fully saturated with hydrogen. Okay? And then if you look at this one, have you ever heard about skeleton structure? Okay, so if you do it in this way, it will be looks like this, right? Okay, or maybe you can do this. Okay, but if there's the skeleton structure, Okay, here. Can always rotate. That means it could be just here. You know why I drew this one like zigzag, right? It's not just the plane or something, because the carbon is group number 4, so it should have tetrahedron structure. That's why it can't be just either linear or tetraplanar, or but just like zigzag. Anyway, so whenever you do this, you can actually rotate this part here. Okay, so it can be looks like this as well too. Or either way, they can also rotate this one to here and here. So this is some freedom they can enjoy by having just a single one, and which is quite important for you to understand. So later, whenever you dealing with all alkanes, just try to remember, oh, whenever you see something like this, will we only stay in that form? No, they can always rotate either in this form, or they can rotate the end of the carbon bonding, so on. So there'll be a lot of freedom on alkane about in the respect of the rotation. Make sense, right? You good? Okay. So what might be a good example for this one? This is actually not in your textbook, but it's only for your your information. So have you heard about? Do you see the nutrient facts when you buy something? What they normally say is how many grams of saturated fat, and they also say how many grams of unsaturated fat. So here is the saturated fat, same. It's a saturated hydrogen. So whenever you think about the fat, right, like a butter or some other vegetable oil, they all main part of them is hydrocarbon. So when they're fully saturated with hydrogen, like I mentioned, they can always rotate. So what happens in the space? You know, if you look at the butter, it's in the solid phase, right? I'll show you one. So most of the fat, most parts of the fat is just hydrocarbon, right? They can always rotate, so they can stack really well to each other. So that means they can easily solidify in the very limited space. And if that is happening in your blood vessel, what happens? Because heart problems. So this is why, by law, all food industry should indicate how much that does saturated fat there. So that means if there is some grams of unsaturated fat, it's healthier, because the unsaturated fat means there are some double bond. They cannot, so double bond or triple bond cannot rotate. It just stay there. Okay. So this is they cannot stack well because of the limitation of the rotation. This is why they normally stay in the liquid phase. They cannot solidify in your body. And sometimes what they do is because of their, non-polarity on those most part of them, they actually sometimes remove solidified saturated fat in your blood vessels. So we call this healthy oil, like vegetable oil. They have a lot of double bonds in their fat compounds. So it's just for your information. It's okay that would be the example, but it's really always good to know how you can apply our chemical knowledge to real life. So anyway, but it kind of makes sense, right? So now we know what's the characteristic of alkane, what we can expect from those ones in the compounds. Okay. So anyway, so whenever you try to do some naming your alkene, first thing what you need to look at is if there's any functional groups. Functional groups. So functional groups simply is the group of atoms making some kind of a bonds. Okay, so they can have certain type of characteristic on the alkane structure. So this is usually work as independent groups. So that means if you have any certain groups on arcane, either what arcane group you have on with that same functional group, they will still keep the same functionality for any type of chemical reactions or physical property and everything. Normally, when you look at this functional, if you find the functional group on the arcane, those are the ones that we consider quite most important. So maybe you can consider those double or triple bond in this arcane also is good ones you can consider in your arcane, maybe not arcane group, but in organic compounds. So anyway, so this is the most important thing. They usually imbue the compounds with a certain specialized functions. And also, whenever you try to look at the compounds, we also try to number the carbons. This is why we try to memorize the certain way to name the numbers of carbon in your organic compounds. So probably you have done this in your Gen Chem 1 or 2, the math and pro. You guys done this before? Okay. Okay. So if you can do this, okay. Okay. So you guys done this before, right? Okay. Let me hear. Let me hear this. So whenever you try to name the organic compounds, obviously, like I said earlier, most important thing is your functional groups. If there's any functional groups, you can change. But also, you need to count the numbers of carbons in your compounds as well. And also, later, there will be certain numbers of carbon in the organic compounds can be in their major longest carbon chain. So they can be actually counted as substitutes groups. We'll get there soon, but let me try to explain this one. So this is something we just kind of have to memorize for the naming numbers of carbons in your longest carbon chain in your arcane groups. So this is just the 1 carbon, 2, 3, 4, 5, and 6, 7, 8, 9, and 10. So how we're going to use this one is pretty simple. Whenever you have maybe 4 carbons in your carbon chain, right there. So we assume there's no double or triple bond, so you can just fill this with the hydrogen. They're all fully saturated with the hydrogen now. Okay. And then when you just need to do, try to find the carbon chain, which is this part right here. Okay. So now you know, oh, there's the carbons in this part. I see this one, 2, 3, and 4. So that actually goes to bute. Okay, bute. So as we know, there's no double or triple bond. So we know this for sure is arcane. So arcane, and there's a bute over here, right? So I'll just put that bute here, and I'm gonna put A and E next. So it'll be A and E. Okay? So this is butane. This is how you can name the organic compounds. So as you can see, if you look into the textbook, what it says actually is this is where you can put the some information about the functional groups or the original structure. So maybe you can call this suffix. So suffix simply means it's like your surname, your like a last name. That means, I don't know, can you change your first name for sure, right? If you want to. I don't know if you can change your last name. Maybe you'll be able to, but it'll be harder than what? Changing your first name for sure, right? So that means you always consider suffix is the most important part of the name. So I'll tell you why a little later, but make sure you record the suffix because this is the most important part of your name of the organic compound. And this is where we put the numbers of carbon. We call this base. So technically, it's literally just base. Like base simply means where you can find the longest carbon chain. So they will make some like a base for any functional groups or for the substituent groups. So you can have all the structure in your organic compounds. So we just literally call this base. This is the way you can count the numbers of carbons in the longest possible carbon chain over here. So let me give you one more example from here. So now this is the suffix, this is the base, and this is where we can put the substituent groups. We call this prefix. This is where we can put the substituent groups. And there are some parts where you can call locant. They just simply try to point out where the substituent groups are in your organic compound. So let me change this one a little bit. Okay, maybe I'll add 2 more carbons here. Okay, like this. So here's the thing. Now adding 2 more carbons on this carbon here, it changed everything for this compound. If you look at this one over here, now these 4 carbons are not in the longest possible carbon chain anymore because of those 2. So if you actually go to this way, it actually gives you 5 in your carbon chain. So then that makes this one as now substituent group, which that belongs to your prefix right here. So if that is the case, I'll do this again. So there's no double or triple bond, so it'll be still A and E. This is the most important part, so I'll do this first. And now I find the longest carbon chain, and I find the 5 carbons there, not 4 anymore. So there will be pent. So now I know it's pentane, but we actually had a 1 substituent group on this center carbon on your base. So if you look at this one, there's only 1 carbon with the 3 hydrogen. So that is what we call a substituent group, methyl. It simply means there's only 1 carbon in your substituent R group there. Okay, and then at last, what you need to do, you need to tell me where is it? Where is your methyl group? So you have a carbon 1, 2, 3, 4, 5. So you can say this is number 1, 2, 3, and 4, and 5. So now you see the numbers of the carbon where you can find the substituent group is number 3. So you're gonna say 3-methylpentane. It doesn't matter you come from this carbon 1, 2, 3, 4, 5, because it's still 3. Okay. So the final name for this alkane is 3-methylpentane. Makes sense, right? Yeah.
Is the methyl just CH3?
Yes. Yes. Perfect. That's a good question. So if there's a 2 carbon, it will be ethyl. Some scope goes propyl and so on. So it depends on how many carbon the substituent group has for the carbons. Perfect. So let me change this one a little bit now. So I think we got this one. So this is a locant, prefix, base, and then suffix. So how about we change the location? So everything is the same, but we change the location here. So maybe we have methyl group right here instead of here. Okay? So here's one thing what you can do. If you try to locate your substituent group here, and some people will try to count the carbon from here or here. So if you count the carbon from here, it'll be 1, 2, 3, 4, and 5. But if you count the carbon from here, it'll be 1, 2, 3, 4, and 5. So in this case, as you can predict for general rule in chemistry, you're always going to choose the lower number for that location. So if you count the carbon from here, it'll be 4. If you count the carbon from here, it'll be 2. So in this case, I need to choose either 2 or 4, but I always like the lower number, so it'll be 2. Okay? So this is just something you need to do when you try to locate your substituting group and the one side of the compounds. It always going to follow the lowest possible local number, either among your choice numbers of choice. So it'll be 2. It makes sense, right? Here's one thing. There will be only one exceptions that you can possibly make on this one, because as I said earlier, whenever you have, for example, let me do this once more. I'm sorry, it's just kind of messy. So here, okay, and then you have maybe here. Okay, so if you try to do in the skeleton structure, maybe it looks like this. Okay, you know this. So can I do this way too? Okay. So whenever you do this, it looks like this, right? But there's only one possible scenario. It overturn this decision here is your suffix, because this is arcane, but maybe we had a double bond on here on this side of the compound. Now it becomes pentene, right? Pentene, change the EN. And then, like I said earlier, is better. So you can find the double bond in these two carbons here, right? And it is always better to put the lower number for the location of the suffix. It's more important than putting the lower number for the location of the substituting group. So in this case, we cut the carbon from here. It would be 1, 2, 3, 4, and 5, right? But if you cut the carbon from here, 1, 2, 3, 4, 5, you can get the lower number for the location of your suffix, right? Then you always count the carbon from here, so you can give a lower number for suffix, because suffix is more important than prefix. Okay, so in this case, you change this one. Okay, you change this one to 4. Okay, then it's okay. This is the only case you can overturn your decision on the number for location of the substituting group. And when you locate your double bond, your suffix, what you can do, so now we know we can count the carbon from here, right? 1 and 2. And obviously, we always follow the lower number, which is number 1 carbon. And then what you need to do is just locate your ENA here, like this. So 4-methyl, 1-pentene. Some people prefer, because it's actually location for this one. Some chemists use 4-methyl, pen 1-pentene, like this. But it's the same thing. You don't have to worry about which one you need to choose. Either way is fine by me. Because, but it kind of makes sense. They wanted to do this way because they actually want to locate the suffix, not the whole pentene. Does it make sense so far? We good? Okay, good. So, and now we can see, how about we have more than maybe one substituting group like this. Okay, so in this case, it's pretty much the same, right? When you try to do this, this is still longest carbon chain. So you can still keep the pentane base here. So if you go this way, this way is fine. This way, actually you can go this way too, but still substituting group on this side too. Okay, actually make it even easier. I'll make it even easier. Let's try to do hexane. Okay, so here we have a 2 like this. Okay, so in this case, can you guys guess which carbon you need to count first to get the lowest possible number for the substituent groups? Which those two? Will be here or here? This one perfect. So same. That's good. So no matter if you have more than one substituent groups, still you can look for the carbon that can give you the lowest possible local number for the substituent group. So we had the 1, 2, 3, 4, 5, and 6. So now we know how to name this one. Here will be first of all there will be 6 carbons, right, in total. So it will be hex. And this is still alkane, so hexane. Okay. And now we have 1 and 2. So it will be 2 methyl, right? And then the location will be not. So if you count the carbon from here, 2, 1, 2, 3, 4, 5, and 6. So it's not going to be 4, 5, but it's going to be 2 and 3. Because this is a lower number combination than 4 and 5. So what you can do, I'm gonna do 2 and comma, okay, and 3, because there's a way number 2 carbon, number 3 carbon, where you can find those methyl groups here. And now you have a same substituent group twice at 2 different locations, and now you're gonna put methyl here, but please remember you put dimethyl. So di simply means 2. So you can do mono, di, tri, tetra, but it simply means there are 2 methyl groups on carbon number 2, carbon number 3, and which is much better choice over carbon number 4 and 5. Okay? So far so good? Good. So if we have, let me see, I'll make it even longer. Okay, so how about we have like this? Okay, so maybe not just 2 methyl groups, but we have 2 different, like 2 different substituent group. So now this is actually not methyl but ethyl, and this is the still methyl group here. I'll remove the numbers. Sorry. So in this case, we still need to count the carbon from here. You guys kind of make it makes sense, right? Okay. So it'll be 1, 2, 3, 4, 5, 6, 7, and 8. Do you guys know if it's 8? What's the name? It's octane. So now it's octane. Okay. So in this case, you have 2 different the substituent group. The problem is how you're going to order them. Okay, so the problem is how you're going to order this one on over here. So this is, like I said, 2 carbons as substituent groups. So we after here, this is 1 carbon methyl here. Okay. In this case, what we need to do is we locate these 2 first, 2 and 3. Okay, instead of counting from here and then, the 6 and 7. 6 is better, choosing 2 and 3. And we're going to order this one by alphabetical order. Alphabetical order. So what I mean by that is you put this N here and E here. And in alphabetical order, which one comes first? E, right? So we're going to put this ethyl group first in the name. So there will be on carbon number 3, so 3 ethyl, okay. And now it's 2, right? 2 methyl octane. Okay, this is the full name for this compound. It kind of confused sometimes because this is in the lower number carbon, so you may want to put the methyl first. No. Whenever you try to order two different substitution groups, you always going to sorry, you're always going to put the substitution group in alphabetical order, without regardless of the numbers for the locals. Okay, it makes sense, right? So far so good. Okay, I'll just do one more, and then I think it should be good enough today. I'll try to do more on the nomenclature next Monday, and probably I'm gonna go on to other parts of the chapter 3. But this might be almost done. But just a little more today and a little more on Wednesday, and then we'll be done. So anyway, so now we have this one. But how about this one? So sometimes this is the, I think this is most like the trickiest, challenging problem. One of the problems you may see on the, let me throw it there real quick, on the exam. Okay, so maybe you have this. Okay, so now you have methyl group here, and also there's another methyl group over here too. Okay, so now you have three substituting groups, right? You have three substituting groups. So we'll keep the still longest chain will be what? 1, 2, 3, 4, 5, 6, 7, 8. So you can still keep the octane over here. That's fine. Now the problem is now you have a 2, which is 2 and 3, right? And it will be dimethyl, okay, group here, and this is a 3 ethyl group over here. And so, like I said before, whenever you try to order the substitution group in front of your base and the suffix name, you need to do this alphabetically, right? Okay, so so actually, when you do this, now D comes first, then E, right? Because it's now 2 methyls, it'll be dimethyl. So if you put 2, 3 dimethyl, 3 ethyl octane, that is wrong. So what I mean by that, I know it's confusing, right? So when you do the alphabetical order, those like a di or tri or mono, tetra doesn't count. They don't count for alphabetical order. You're always going to count what actually your group, your substituent group name, which is methyl. So still, we count this in alphabetical order as M, not D. So it actually comes later than this one. So does it make sense? So whenever you do order, you see D over here. Oh, so maybe this comes first. Dimethyl and 3 ethyl octane. Okay? And that is wrong. Because you count not D but M and E. So it'll be still 3 ethyl, 2, 3 dimethyl octane. Oh, sorry, it's out of my camera. Okay, the 2 and 3 dimethyl octane. Okay. All right, it kind of makes sense, right? Super, so good. Okay, so just one more thing I want to point out too. Just this is a quite important part. Only couple one more thing I want to. This also this type of question will be on the exam for sure, right? This is very important part of chapter 3. But if you can follow this instruction somehow, like how you can arrange this substitution groups in your name and everything, you'll be just fine. There'll be another possible exam question you may see on the exam is this one. So whenever you look at this one here, this carbon, Okay, so they should be in this way, right? So whenever you look at the carbon here, only carbon that this carbon is making to the single bond is this carbon here, right? So in this carbon will be what? This, all three, let me read this in more detail, will be hydrogen. Only one carbon making a covalent bond to this one. We call this carbon primary. Primary, because there's only one carbon, they made a bond here. If you look at the carbon in here, there's only two hydrogen there. This carbon making a bond to this carbon and this carbon, there's two, right? So we call this carbon secondary. Secondary carbon. Okay, right? If you look at number two, carbon over here, this carbon is bonding to this carbon, and this carbon. There's only one hydrogen here. So this carbon we call tertiary carbon. It only depends on that specific carbon is making how many covalent bond to the other carbons. So if there are three, now it's tertiary. So obviously now, if you look at the carbon number 3, there's four carbons are making covalent bond to this carbon number 3. So we call this carbon quaternary carbon. So that means there are 4 carbons around the carbon making covalent bond to it. So this might be very easy, simple. Most likely exam problem you may see on the early October. Okay, it makes sense, right? It's just simply you need to count how many carbons making a covalent bond to that specific carbon. If it's 1 primary, 2 secondary, 3 tertiary, and 4 a quaternary. Makes sense, right? It's pretty easy, right? Oh, perfect. So thank you guys. You guys did so great today. So that'll be all for today. Perfect. Thank you.